Right, proving triangle congruence by angle side angle and angle side, ASA and AAS. So angle side angle, if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So notice the included side is the side that's stuck between the two congruent angles. It's the side that connects them. So if you draw a path from one congruent angle to the other congruent angle, that is the included side. Okay, so we're going to use that proof, or that theorem, to help make some proofs here. Let's complete some proofs. So, using the angle side angle congruence theorem, write a proof. Given AB is parallel to ED and AC is congruent to EC. So when I'm looking at this, if I kind of just think through my proof first, there's AB, there's ED, those are parallel lines. Anytime you have parallel lines, always trace your transversal. So there's one transversal. That means that this angle, angle A, is congruent to angle E. This will give me an angle. So we have an angle. We're already given a side. So really we need one more angle. Angle, side, so the connected angle would be right here. Angle, side, and connected angle. Well, those two angles are congruent by vertical angles. All vertical angles are congruent. Okay, so I've got kind of a plan there. Now, statements and reasons. Let's check that out here. So the first one, my given, AB is parallel to ED. That is given. Based on that given, I know that angle BAC is congruent to, well, B corresponds to D, E corresponds to A, E, and C to C, to D, E, C. How do I know that? Well, those are alternate interior angles, and alternate interior angles are congruent. So there's my angle. All right, so I'm going to go ahead and mark that. I'll use 2 marks. Okay, number 3, I know that AC is congruent to EC. I know that because they give it to me. That's given. And so there's my side. Then number 4, I have my vertical angles, my BCA, angle BCA, is congruent to angle DCE. So B corresponds to D. So DCE. Okay, and that is because of vertical angles. So finally, using my, don't want to use that, angle side angle. Okay, so finally there, I'd have triangle ABC is congruent to triangle EDC by angle side angle. All right, that's all there is to that one. Okay, one other theorem we have is the angle side theorem. Angle side says if you have 2 angles of one triangle congruent to 2 angles of another triangle, as well as a non-included side. So in this case, a non-included side is a side that is not on the path connecting those 2 congruent angles. So if you drew a line from angle to angle, that is the included side. So you have 2 non-included sides. You just need one of those. Okay, and just understand really why this works. This is the angle side. We just had the angle side angle. Okay. Well, remember, there's a congruence theorem that says if 2 angles of one triangle are congruent to 2 angles of the other, then the third angle is also congruent to the third angle of the other. And if I had that, like if I actually had a third angle marked in here, that we already know because they have to all add up to 180. Okay. If I had that, I'd have angle side angle. That's why this congruence theorem works. It just kind of saves us a little extra time. Okay, it's derived from the angle side angle theorem. Now note we have 5 different theorems now if you follow this whole teaching lesson here. So we have angle, side, angle, 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 side. In previous lessons we've done side, side, side. We've dealt with hypotenuse, leg, and we've dealt with side, angle, side was our first one. Okay, this is today's, and more specifically, this is the one we're dealing with right now. Okay, so our last proof here, using the angle, angle, side, or congruence theorem, write a proof given AD is parallel to CB, so AD is parallel to CB, and angle B and angle D are right angles. Okay, now anytime you're given parallel lines, remember you want to trace those parallel lines and then trace the transversal that goes through them. In that case, I know that this angle right here is congruent to this one. Okay, I'd have that by alternate interior angles. So by having parallel lines, I also get a congruent angle out of it. I know that BD and B and D are right angles, and I know that those are also congruent to each other because they're both the same measure. All right angles are congruent, so I get another angle out of it. So all I need is if I'm going to use angle, angle, side, all I need is a side that's not included between the two angles. So here's angle, here's angle. Well, I get this side right here, which is not included by reflexive. Okay, so I've got angle, angle, side. Okay, that's all I need. So there's my plan for my proof. Here's my statements. Here's my reason. Number 1, AD is parallel to CB, not E, CB. That is given. And using that given, I'm going to go number 2, angle DAC is congruent to, well, D corresponds to B, so BCA. And that is alternate interior angles. Alternate interior angles. Whoa. All right, got all kinds of things coming on the screen there. Okay, and then number 3, I know, and by the way, that's one of my angles. I know that angle B and angle D are right angles. And that is also given. But that given allows me then to state option 4, which is angle B is congruent to angle D because all right angles are congruent, or the right angle congruence theorem. That is my side, or excuse me, my other angle. And then I know that AC is congruent to CA, and that is by the reflexive property. There's my side. So now I have triangle ABC is congruent to triangle CDA by angle, angle, side. There we got it. Good to go. Well, that's all I got there. Good luck.